Hi, my name is Dingyan Lim, and today I'll be discussing the use of eggs as emulsifiers. Emulsifiers are a group of compounds that help to dissolve two typically immiscible liquids into each other. Now, to dissolve a compound, let's say compound A, into another compound, let's say compound B, compounds A and B must be able to intermolecularly bond with each other. However, in an emulsion, compounds A and B typically have a significant difference in their relative polarities, with, let's say, compound A being relatively nonpolar and compound B being relatively polar. Since polar compounds primarily interact only with other polar compounds, compound B will almost exclusively interact with other compound B molecules and will almost never interact with compound A molecules. As such, there'll be very little to no intermolecular bonding between the two. It is because of this lack of interaction that in emulsions you can see the solution separated out into multiple layers. Now, how an emulsifier works is the emulsifier contains both a polar and nonpolar end that allows it to bond to both the polar and nonpolar molecule, effectively acting as the intermolecular bond between these two. With this pseudo-intermolecular bond established, the solvent compound can now bring the solute compound into solution, or in other words, the solvent compound is now able to dissolve the solute compound. For eggs, the egg yolk contains this compound called lecithin, which has these two nonpolar hydrocarbon chains at one end of the molecule and this charged phosphate group at the other end. This lecithin is what allows eggs to act as an emulsifier and is what makes them so important in various sauces and condiments like mayonnaise. Today I'll be using egg yolk to try to perform an acid hydrolysis of an amide bond found in capsaicin using lemon juice. Capsaicin is the compound that is responsible for the spiciness in chilies and is effectively insoluble in aqueous solution. Similarly, the chili oil that I'll be using as my source of capsaicin today is also effectively insoluble in aqueous solution. Obviously, this poses a problem because in order to hydrolyze the amide bond, I need the capsaicin and acid to be able to interact. This is where the egg comes into play. By adding egg yolk into the acid capsaicin solution, I should be able to bring the capsaicin into solution, allowing it to interact with the acid. This should allow the carbonyl to be protonated, after which it can be attacked by a water molecule, forming a tetrahedral intermediate. After a proton transfer from the water molecule to the nitrogen group can then be kicked off, forming a protonated carboxylic acid and an amine. This amine can then deprotonate the protonated carboxylic acid, giving us the desired product. So I'm in my kitchen now. I beat the egg yolk and put it in a small container. And then this is the chili oil I should be using for my reaction. There are some contaminants in forms of other ingredients, but I don't believe any of these should cause any noticeable side reactions. I've set up a set of 3 vials that I'll be adding a small amount of chili oil to, along with some lemon juice, which I'll squeeze from this lemon. Typically, acid hydrolysis is conducted using a very strong acid like hydrochloric acid, but since I'm using such a weak acid, comparatively, citric acid, I'll be trying to shift the reaction towards equilibrium by adding excess acid. So as you can see here, I'm just trying to fill it with acid until it just about fills up the bottom, and I'll be doing this with all the other 2 vials. In these vials, I'll be having 1 vial with just citric acid and the chili oil. Be adding the egg yolk and alongside the lemon juice and chili oil to another vial. And then in the last vial, I'll be adding water and chili oil as a sort of taste control. Because for this experiment, since I don't have any fancy lab sort of instruments, my way of testing to see how effective my reaction will be using pH paper to see if the acidity drops to suggest that the reaction occurred, and by tasting the reaction to see if it seems any less spicy to me. So as you can see, if you look at the oil lemon juice pure, or just the oil lemon juice vial, you can see that the two don't mix at all. Even when I shake up the container, you can see the bubbles forming, suggesting an emulsion is happening. Now that I've added the egg yolk into the lemon juice oil solution, if I shake it up, we should be able to see some of the oil dissolving into the lemon juice. So yeah, as you can see, after I shake it, it looks pretty homogeneous. I'll now be setting up a hot water bath to heat both of these reactions. I'll let that run for around an hour or so, then I'll be taste testing my results. Because I forgot to show this before I put the lemon juice in the vials, if I take a strip of pH paper and dip it into some lemon juice I just squeezed again, you can see that the paper is indeed acidic, and if I try to compare it, I guess this is hard to see, but it matches up fairly closely to a pH of 4. So yeah, so lemon juice should be around pH of 4, and if the pH increases after the reaction, then that should be fairly indicative that some of the acid has reacted off. So I've allowed the reactions to basically come to completion, and as you can see, this solution, which is the egg, lemon juice, and oil one, has become a fully homogeneous solution. The emulsifier worked, whereas the lemon juice and oil and water and oil ones have remained as emulsions. Actually, I had to redo this vial because during my experiment, the original vial spilled and some water got in, and I noticed an interesting effect where the solution actually did not, remained as an emulsion, likely because of the introduction of so much water. The egg emulsifier couldn't actually dissolve all of the oil into the water. And so as a test, I decided to use sesame oil and test various concentrations of sesame oil and water, with this one being primarily sesame oil and this one being primarily water. And as we can see, after I had added egg yolk into all of these vials, the one that was primarily oil was able to become a homogeneous solution, whereas all the other ones, which had a significant quantity of water in them, all of them stayed as emulsions. So that's something very significant about the use of egg as an emulsifier. In order for it to work, your solution will have to be primarily oil. Hence, for this, when I redid this vial, I ended up using a much lower concentration of citric acid and just added more egg yolk. Now for the pH test, I have my pH paper right here. If I take the pH of the egg with the lemon juice and oil, the pH ends up being somewhere closer to 5, I want to say. So initially, citric acid has a pH of 4, and this solution has a pH of 5, suggesting that the reaction did actually proceed somewhat. I'll be taste testing this solution to see if it does seem less spicy. I have both milk and water here that I'll be using to cleanse my palate after tasting the solution, and I'll be comparing how this solution tastes, or how spicy this solution is compared to the citric acid solution, and then the water solution. As expected, this solution is still somewhat spicy because not only a small amount of the acid was able to react. The lemon juice oil solution does seem just a bit spicier to me. But of course, it could perhaps be a placebo effect. So this would obviously be better if I had laboratory equipment to confirm if I've broken down the capsaicin. Now for the oil and water. This one is also pretty spicy. It does feel like it has a stronger burning effect compared to the egg lemon juice solution, or egg lemon juice oil solution.